Alright, we should be back now. Oh, it's a pain in the butt. Alright, so let's get back to where we were. So, why did it crash? Oh, we put the spheres down, right? Hey there, Clow, Pete. How's it going? Yeah, so I don't know why we got that GPU crash. Oh, we kept up in the spheres, but why did it still crash? It would have gathered. Hmm, I don't know. I don't know why it crashed, to be honest. Like, it shouldn't have. It should have just grabbed data and interpreted it wrong. Not sure why there'd be an infinite loop. We only really loop on the number of spheres, and we just had 4. Oh no, maybe we would have binned them in the tile binning. Actually, we still have that system. Right. Okay, so 40, 40, 40, 10, 10. Right, so we should produce 4 spheres. Hopefully not crash this time. There we go. I don't see 4 spheres. Let me see 2. Right, they're sort of on top of each other somehow still. Or yeah, they're inside each other. Why was that? They've got a sphere radius of. Oh, okay. Maybe they need to be 30 instead. Right, why are they still joined? Have you got a radius of 10? Right. Sorry, my mistake. No, it should be 20, 20 apart should be fine. If we was to go 30 apart, does that? How does that work? So your radius of 10. So from the middle to the edge, 10 units. You got 2 with 10 units, that's 20 apart. Um, oh. Right, okay, it's that one. That's the problem. It was up against the other one up here. Right, so then that was... Okay, I did my numbers wrong. Excellent. Right, so we've got 4 spheres next to each other. We should probably move them down so we can see it. So let's do like negative 20. Is that good enough? Probably a little more. There we go. So we'll get like those 4 there. We'll get another 4 up here or something, and then we'll put BVHs around them. We put a BVH node around them, which we haven't really done yet at all. But we'll place them ourselves, and then we can. Then in the next stream we can sort of actually make them automatically. Right. So maybe we put them a little bit more to the left. Hey RCT. Yeah, true. I usually don't like using the plus plus operator, but it does make sense in this case. It would have saved me that, wouldn't it? Oh, but I got a question. How have you what's the way to say it? How do you feel like the performance is on this NVIDIA thing you've implemented, the BVH thing? Because last stream when you suggested this to me, I thought I already read it, and I was like, oh yeah, it's too slow. But then what I was actually referring to was this more optimized paper here. So yeah, this one's probably good for if you know, basically offline, if you have the time to just, do this offline. You can kind of do it in somewhat real time anyway, but about 200,000 objects in their one does it 9 ms, right? Um, so I was thinking, it's too slow, but then this one here is like super duper fast, and I think this paper was released 1 year later. So I'm not sure how it compares though with the race speed. They probably mention it in the paper itself. I haven't read it. Yeah, definitely. So this one actually has a paper on it, and this one tells you this is what we're going to be implementing on Sunday, and it's a way to quickly do it. Yeah, but triangles are the same thing, right? Like you just need to get the bounding box of a triangle, right? Oh no, they might split the triangles, isn't it? Oh yeah, true. Okay, then this one is the optimization, which I'll probably look into like when I need it, which is probably for a long time. Maybe when we've built the editor, I might do it for a bit of fun, but other than that, I might not need it. It depends, right? Depends how good the first solution is. Right, so I think that's good enough. We can pretend to put a box there. Let's pretend to put a box up here, then let's just build a BVH, right? 2 levels, done. First 12k objects, right, okay. So technically scale that one, and you probably get similar sort of times anyway. Maybe. I wonder where their previous one is. Yeah, but they split their triangles. Yeah, I wonder where their sort of parallel one is, or their parallel one is, but anyway. Probably keep it there for a bit. Right, let's duplicate that and just flip the signs. But yeah, what sort of times have you been getting? Has it been good enough for you, RTC, the BVH we're going to be building on Sunday? Right, ought to be good enough. There we go. Spheres. Maybe put these ones a little bit higher. Haven't timed it. Fair play. It works though, right? Good enough. Ship it. Right. So now, like any good programmer, we're going to hard code our BVH. So we're going to basically hard code boxes around here and just pretend we have a BVH. So we'll put a box around 2 of them, box around 2 of these guys, put a box around those 2 boxes, and then do the same for this one, and then put a box around all those boxes. 3 levels, I guess. And then we'll just do a nice visualizer for that because, it's a bit of fun, and also it'll be cool to see this in action, right? We'll be able to test our code that we're doing on Sunday, right? And I also get to use my UI system, right? So I actually get my UI system in here, and we'll have a bit of fun with that, right? So let's go full ham. So we need a new shader. So we simply grab an old shader, because that's how everyone does shaders. We grab old shaders. And actually thinking about it, we probably also need a so BVH viewer. We also need to define our BVH node, right? I'm just implementing some PDE grid solver, but they use Lgen, which isn't compiled with good on Windows, so I'm going to rewrite it. What is that? PDE grid. Okay. Grid free partial differential. Oh, partial. Okay. Right. Yeah. Yeah, I understand what so yeah, partial. Yeah. I sort of understand what it is. I don't know what Lgen is. Oh, Egen. I don't know how you pronounce that. An I. What is this? Template library for linear maths. Right, fair play. Right, okay. Fair play. Yeah, templates. Templates. Yeah. It's cool. Egen value vector, I guess, right. Yeah, I'm not sure what that quite means. That's what I want. Right, so our pixels outside the coordinate, outside the, sorry, our coordinates outside the, pixel coordinates outside the dimensions of the screen. Yeah. Then return. So we calculate the ray direction. So all we're going to be doing, right, is we're simply just going to be looping over all of them. We'll traverse down the tree. We'll literally go down the whole tree and simply just ray trace against a box. And if we're at the edge of the box, we draw the pixel. So let's go ahead and design ourselves a BVH tree, shall we? iGen. Right, okay. It could be E or I never know. But yeah, thank you. Oh, gun. I gun. Oh. Now I am super confused. Okay, it's German. Gotcha. Uh. Hey, they're not so red. Yeah, doing good, doing good. Just, oh, yeah, been a weird week this week. I basically had a list of tasks at work that I was going to be doing. Well, no, I have this sort of main task at work that I'm going to be doing, but this week, absolutely none of it. I've been fixing bugs, and I had some other thing I had to do. So basically, and tomorrow is Friday, you know, Fridays are those days at work where we technically don't have allocated time for work, and there's mostly just meetings, but sometimes we do work. And they got a presentation that I'm doing. So I've not touched my main task at work, and it felt weird. I had like a whole week off it. Confused me. But all the things are now done. So what's pretty cool is I can actually just next week just get all back into it, I think. Fingers crossed. I worked on site this week and it was hella painful. Oh damn. Are you doing part-time remote when you've sort of established yourself? Sort of been onboarded, shall we say? Uh, right, so we need a BVH. Right, so how does one BVH? That's a good question. So here we go. BVH, hopefully no other thing has BVH. If not, it's got to rename some things. BVHs. So inside the graphics shared, we're going to put one of those BVH struts. So now, what we need is simply an axis line bounding box, center position, and a half size, right? And the other thing is we also need a link to two. We need a left-hand side and a right-hand side. Because with a BVH, you could technically do more, but I think it's like a standard BVH is just basically a binary tree, and it kind of makes sense to do it that way. Except for the fact you'll be linked listing around a little bit more. But yeah, so you could probably link to a single. Yeah, so I'm thinking I might put the siblings next to each other, because then you won't link list. So you could probably just do, yeah, you could probably just say like children's start, or children start index. So you'll point to the left one, and the right one's just 1 plus that. So if you, and then if you don't have a node, we might use up 1 bit somewhere to say if this node is valid, or maybe just have it as 0, 0 or something like that, and you avoid a branch or something, right? In the code, because it's going to be executed in parallel anyway. Yeah, I'm having a problem with their tooling and frameworks. I have to go to the office for now. Oh, fair play. Yeah, you start to realize when you work in a company like how much in some respects it's quicker to sometimes work with people because they know things and you can sort of talk to them and stuff. But then also how much slower you will work because of the complexity of communicating with other people or having to plan and sort of come to an agreement, and also you might be doing something and someone comes along and it's like, oh, I found this problem in your thing, and then you have to we don't have to sometimes, but sometimes it's just better just to sort of deal with it there and then. There's all these things that you don't have when you sort of develop stuff on your own, and yeah. So, but yeah, I still don't know what it's like to work for like a massive company. Like where I work now is the biggest, so we have like I think it's like 100 odd people. But I can't imagine what it's going to be like for like over 1,000 people. Just the amount of, well, we don't have like 100 developers, right? But yeah, I can just imagine how chaotic it must be with like the repos and stuff. and all the tooling. So one thing about this BVH is that it's already looking at like half a cache line, right? You know, because you can fit 16 4-byte things. We've got 7, right? So I think we should be able to like make these fixed point 16-bit things, right? Integers. Bear in mind we'll have to sort of do that ourselves. And we might then be able to fit 2 of them in a cache line next to each other, right? Which would make a ton of sense. Wait, no. Sorry, we could fit 4 of them next to each other instead of 2. 2 kind of makes sense already because we've got a left and right child, right? It's a binary tree. But if we can fit 4, it will be hopefully better when you're traversing it. And, you know, because this is a... you might have shared cache as well between the shaders, and if one shader hits one which is nearby that one, it sort of like loads it in, and you know, or maybe it's yeah, as you can see it being beneficial, but we won't do that now because it's always great seeing if it's better. So we'll just do the slow thing first. We'll do the easiest thing first. So there's our BVH. Let's construct our BVH. So we'll go to the thing, right? We're literally just gonna make a buffer, and we'll call it like BVH tree. So things about the BVH is there's probably going to be, you know, I think in like the ray tracing APIs, you have top level and bottom level BVHs, well, acceleration structures in Vulkan. So we'll probably do something like that system, where you'll pre-build the bottom levels. So for each mesh is a bottom level BVH. And if it's a static one, it shares the same BVH. But if it's dynamic, it gets a custom one made. And then the top level will be another BVH tree, which is its leaf nodes will be more BVHs, right? Just linked to another BVH tree. But we'll deal more on that later. And I think we might have a special bit to say that is a leaf node. So we'll see how we get there. So let's just allocate the buffers first. Yeah, so much easier to get help when you're in the office. That's right. Yep. When I'm home, it takes hours to get a response. Really? That's not good. Like for me, you message anyone on my team, you basically just get a response within, you know, it's pretty much instant most of the time, but sometimes people step away for a bit, and you know, you get 15 minutes max. Really, you know, not really too much of a problem. Have you not got like a little local boss and team members and stuff? Don't Google use a monorepo? Yeah, they have some like, I don't know what Google do, but they have some like super custom tools to like do a ton of stuff. Yeah. Mm. You working like a big company, or how many people working at your place? Not so red. Right, BVH buffer. Buffer of BVHs. So all we're gonna do is simply BVH. So how many BVH nodes we're gonna have? Good question. BVH buffer cap. So yeah, let's just say 65,035, right? Or 36. 16-bit baby. Right, so we've got ourselves a BVH buffer. So now we've got to fill this bad boy up. So here's our spheres. Let's simply do BVH Um, so we'll map the whole. Should we map the whole thing? Seems quite dangerous. Let's just do. Well, it's a lot. It's a lot of memory, but we can. Well, it's not that much. Sod it. Let's do it. B, V, and H. Right. So another one. Call it B. Right. So around two spheres, we're gonna put a B, V, H node. So really we should call it nodes, but oh well. Yeah, should we call it? You know, I'll rename it later, it doesn't matter. So effectively we just want to like bump allocate them in here, right? So right, let's do the suggestion. Oh yeah. So we've got a children's start index. So its children is probably going to start at 2. So the thing is, but yeah, the root will I guess just take up the first. Yeah. Children start 2, and then what's the other one? Center position. Right. So center position between all of these is 0, 5, 7. Wait, that's in the middle of the whole thing. We just want the middle of one of them. So do 0, 5. Oh wait. Oh, it's a small company. Fair play. Yeah, it's a good place to start. Small company. Get to do a lot more stuff, I reckon. Should be cool. Yeah, yeah. Do you work on a Monday to Friday, or is it part time? Right. So center position between these two balls is or two of the balls across the Z axis. Well, we've just done it across the Z. Yeah. I guess. Sure, that should be good enough. And then the half size would just be like 10 across the Z axis. Half dims be like 5. 5. No, it's like radius. It's just radius, so it's 10. Yeah, sphere radius. Right, to be 0, 0. Monday, Friday, fair play. Nice. Right, so there's one BVH for these two spheres. Just plop in here. There's one node for those two. So that one's kind of, at the moment, the root. But yeah, we'll need to patch them up. So let's just copy this one and let's get the code all cleaned, all lined up properly, and then we'll edit the BVH things, right? So basically we've got another set of 4. So these are the top right set of 4. So they do 2 there and 2 there. And then we need to just do simply just But it's 9 till 6 and basically out the whole day. Yeah, that is about how much I work, but I work from home. I work. Oh no, I work 9 till 5:30. Yeah, you're a little bit longer than me. Yeah. Yeah, it's weird. Like an extra half an hour from the 9 till 5, you know? Standard 9 till 5 times. Um, yeah, I think I used to work 9 till, what was it? Yeah, it's 9 till 5:30, I think it was as well. My previous place. But yeah, my brother used to work 8:30 till 7 or something dumb like that. And he used to work Monday to Friday, right? And then he even used to work every other Saturday. And he just like rented out, um, rented those on sales basically. He's rented out apartments or whatever, right? Just flats, houses or whatever in Guildford. Um, it was just insane, like how much they wanted him to be in, even though he should decide that well, he should, you know, he's driven to work harder by how much money he will want to take home. So but they wanted him in all the time, which is crazy. Yeah, he recently just got a new job though. And he's actually got it quite good now. He's got it slightly better than me. He works 9 till 5, and he still does sales and stuff. He sells like electric cars now. But yeah, just absolute crazy. Like, oh yeah. To be fair, I used to travel like an hour for work as well. Uh, but now I don't do that anymore. So much better. Hopefully it stays that way. Um, right. So as you can see, we've got layers of BVH now, right? We've got root, and obviously the second child, and then the actual children here, right? Oh, we need another layer. Whoopsie, missed it out. Need another layer of BVH. Rightio, let's plop these ones in. Then we've got to fill in the data. Okay. Oh no. Right. So it's just a binary tree, nothing special. And now we've just got to fill in the data appropriately. So we just fill in the top ones, the ones below just mirrored. So it should be quite easy to remember. So we've already filled in this one. So this one here is in between. Wait, it's the same thing, isn't it? Oh, just 60 is the half. Yeah, the Z has only changed. Good. Then this one is the parent of those two because there's four next to each other. So this one would just be 70 and that one would be 05. Then with that right though. Yeah. Is it really a radius of 10? It should be two balls you're fitting in there. So it should be 20. I think these are 20. 20, 20. Yeah, because you're in the middle of the oath. Yeah. 5. Oh no, it's a half size. Sorry, it's 10. It's definitely 10. Half a radius, 10. Excellent. So the other one below is basically the same, but we just flip the axes. So we just need to like literally just copy paste these guys. and jobs are good. So that one goes there. That one goes here. This one goes there. Right. Okay, then we just flip these signs here so it ends up in the top right of the screen. Excellent. Now it's got one more to do, and that is this one here. And then we'll just double check all of it. And then we'll get right into some GPU code to actually visualize this box. So this one's got to wrap all of them. So we've basically got to get the midpoint. Yes, it's basically 0, 0 is the midpoint, center of the screen, right? We specifically mirrored it to make things easier. Now the dimensions is obviously, so the furthest one away is 80. So it's 80 times 2. Quick maths, 160. Boom. Then for the y coordinate, it's 50, isn't it? Yeah, so it's 100. Wait, but it's the half dimensions. So it's no maths required at all. Look at that. Okay, and along the z, we didn't change any. It's still 10 along the z. Excellent. Right. So we've got our BVH nodes inside a buffer. Just allocate that there. We bump it up. Now this child index is wrong, right? It's got to link these guys right, okay? So this one's going to link to 2, right? So we need to bump allocate in a... So the way I want to design it is the children are next to each other. The left and right are next to each other. Because chances are you'll need to check both anyway, right? In memory. So the root node, we could either start on 1, or we could, yeah, let's just make, no, start on 1 would be a bad idea. Let's just make this one empty, something like that, and hopefully we never hit it. And if we do, we'll make it link to, yeah, no, let's just set it to infinity. What am I doing? So that's just a part of a design choice we're doing. Oh, dims 0, 0. There we go. So this one's going to have child index of 0. Now make it recurse though. That'll be fine. It'll be fine. Okay, so you just basically set up the root node and the fake root node that bundled alongside it. Then this one's going to link to 2. 2 is this guy, and its buddy is going to be next door. So really, we should have allocated that with it. Well, when we're building it, yeah, I'm not sure how good of an idea this. Yeah, do you want them to be next to each other in memory? Yeah, because if not, you'd have to link to 2 different places. Yeah, let's just do it this way and see how it goes. And write the code. Okay, so this one links to 2, which is this one. This one links to this one here, so that'll be 4. Okay, and 4 is gonna, now this is a child. So we should really say it's a child, say it's a leaf node. See, technically you should link to the spheres. But yeah, we'll set a high bit, say BVH child node mask or bit. 1 byte, 2 byte, 3 byte, 4 byte, right? And you're just simply going to all that bit onto here. and say we're going to link to sphere 0. Okay, if we hit that one, yeah, whatever. Let's do that. Not that fast. We're not going to be touching the spheres today. We can, when we build the proper BVH, we'll actually deal with it. We're simply just going to trace against the BVH tree itself. So those are fine. Now this one's got a link to the nodes after it, so it's going to be 6, right? Because that's 4, 5, 6. 6 is then going to link to those. And so when you hit a child node, we're just going to stop, right? Easy peasy. So, right, so now it's got to do the BVH shader code. So all we're going to do is, right, so we need to traverse a tree, and you don't have recursion. So what you kind of have to do is have probably a stack. Now, each pixel is probably going to has the potential to be different. So we have to kind of keep a stack of these guys. Let's do 32 for now. So because it's a binary tree, obviously it's just like 2 to the power of n, right? So 2 to the power of 32 is 4 billion. So that handles 4 billion nodes, right? So that's the maximum. Like if you have that depth, you can handle up to 4 billion nodes basically at max. So that's definitely like a good maximum number to have. But we'll see how many we actually use. So we're just gonna say, I guess say while 1. Technically, you want to probably have a max number of iterations, but yeah. Something like that. So what are we going to do in here? Well, we're going to get the, so you have your current, so you have a BVH stack index equals 0, and you also have a BVH index, like a node index. You should really call that node, but anyway. So you'll have your BVH buffer. It's called BVH buffer. BVHs. And you index it with your BVH. And that's going to get you your BVH. Like so. So you basically have to do a reverse box test. So I've got one in the HCC code base, so the custom C compiler I've got, it's up on the GitHub, There's a voxel ray tracer where we basically do an AABB test versus array. So you just want to get this thing, and we'll basically like customize it for what we need. Hey, cool Mac Blue, welcome back. What font is that? This is Liberation Mono. It's great font. It's a free font. You can use it in commercial projects as well. I think it just needs attribution, I think. But yeah, it's pretty good. Right, get a nice epsilon in there. Okay, so you need your T0 and your T1, T-min, T-max. We need T-min, T-max. So what is this doing? It's a reverse box, right? So let's quickly get to some way to draw. So essentially what we have is a view, right? We're shooting an array. And you have like a box. When you're shooting your array, you've got Tmin and Tmax. Tmin and Tmax are very useful right now because what we want to draw is we don't want to draw the box. We want to draw an outline of the box. So if we have Tmin and Tmax, we can calculate hit locations, which means we can actually determine where on the box you hit either side, and if you've hit near the edges, right? And if you've hit near the edge, we want to draw a pixel. So that's basically what we want to do. So we got our Tmin, Tmax, and like so. Then we want to essentially do a sort of like array. We want to get a sort of a hit front, hit back, and then see if any of them land on a corner. So you want to get like a hit front, which would be a Tmin. So it'd be like a mol s float 30 times 3 from the ray origin with Tmin. So that's going to get it in world space. And then to translate it into local space, you need to do a subtract from AABB min. Bear in mind, we haven't got the AABB mins. Wait, do we want mins and maxes? Yeah, I think we're better off with mins and max, aren't we? This algorithm. That means our BVH should really be a min-max. Damn it. For now, let's just compute ABB min-max. Because, yeah, but we can save on the subtractions basically, right? But anyway, and adds, right? We can save on that. Cool, so you get your Tmin, Tmax. So then we want to subtract by AABB min and just see where we are at. So sub F32 times 3. We're going to sub that by AABB min, right? Now, so we just need to do a back as well in local space. The same thing, it's just bits with Tmax, right? So now we've got 2 hit points in local space. So local space is, wait, sorry, we want to subtract it from, probably want to take away center position, actually. Yeah. So you want a relative position from there, from here to there, and a relative position from here to there. And now we just need to figure out, are you at the edge? Are you at any of the edges, close to any of the edges, right? How does one figure that one out? So what we need to do is so there's a key thing to take away. You're in the middle. So that is like positive 1, say, that's negative 1. So if you absolute it, you can basically, like, we just need to know when we're near the edge, right? So you can, like, if you absolute it, like, the whole thing is like mirrored basically, right? It's you know, the left is exactly the same what it is on the right, and up and down is the same, right? In a sense. So if you can basically just simplify the problem by absoluting the coordinate and seeing how close we are from either the top or right hand side. So we just need to ABS. So we want to know if, so we need to ABS these coordinates and check if we are, and take ourselves away from the half size and see if we are a pixel or two out, right? Whatever our thing is. So I think we've already got it here. Pixel size at near plane. So we need to know our pixel size at front and our pixel size at back. So we need to know our depth. That's our depth, isn't it? Yep. So pixel size at front. I'm using the mouse to draw. Yeah, it's just Milton. Just drawing. It's yeah, you can draw using the mouse. So it's just a multiply between pixel size at near plane multiplied by the depth, T min, pixel size at back. So that's how much we've got to compare ourselves against the edge, right? So we know if we have hit, Boolean is hit, if, so we basically want to get like, want to subtract between, what was it, I'm sorry, yeah, between our BVH dot half dims, right, and our hit front in local space, right? So this will give us in 3 dimensions yeah, how far we are away from the edge. Now we want to find the minimum of that, right? The minimum element of on the XYZ. And then we can basically say, okay, if that's less than or equal to a pixel size at front, then that's a hit. Then we do the same thing again, but we OR it. But we do it with back and against the pixel size at back. So that should do the whole bordered outline of the axis line bounding box. We're just doing a ray trace against the box, and if we hit the edges of the box, then that is a hit. So if we land a hit, you're doing good with the mouse. I'd be writing some aliens. Yeah. Yeah, I don't know, doing alright. I switched over to a vertical mouse maybe over a year ago now, and it took me a while to get used to this vertical mouse. But yeah, I can do like okay drawings now, but not as good as I used to be with a mouse. Not sure if I can draw. I can draw like basic primitives. I can draw circles pretty well. But yeah. It's always fun when you play like a drawing game with a mouse and you sort of like people do the most fun drawings, you know. Like every Friday at work we play like a game. Sometimes we play a drawing game, and it's just fun seeing what people come up with a mouse, especially when they have like such short time. It's a lot of fun. Just yeah, I do on there. Yeah. That's about all I can draw well. I think sometimes I just draw really bad as well, just because it's fun. It's how comical how bad the drawings can be, you know. Good. You can't actually. You're too much of a keyboard ninja to sort of like draw with a mouse. So if we hit, we're just going to color in a pixel. Jobs, good. Are we going to color in a pixel? No. because it's a BVH, we want to say if we've found, like, you kind of want to draw. So that's another thing as well, is we didn't really set like the type of level you're at. Like, oh, I'm at level. Oh no, you know that based on the stack. We know what level we're on based on the stack. So you can say like, oh, I hit. So what's my sort of so I think you. Wait, what do you want to do? Yeah, you want to say closest hit depth. Closest hit depth. And so obviously you say infinity, right? So you basically just say, okay, if it's hit and this, you say then closest hit depth. Hit depth is equal to, what is it? It's T min, right? So that's the closest hit depth along the ray. Now we need to also say closest hit level, right? Because I want to color it in by the level. So we're just going to set that to U32 max. And then we can simply just set it to BVH stack index plus 1. So BVH stack index plus 1. Right. So you might think we completed it. Well, we're not traversing anything, and we're just going to get an infinite loop right now and crash the GPU. So we want to avoid that. I'm sure you can draw a circle. Sure you got it. Yeah, I remember like my maths teacher saying, if you could draw, oh, look at that. Oh, I remember my maths teacher saying, if you can draw like a perfect circle, I don't know where he got this. You know, I think it's like before the internet. You say, oh, if you can draw a perfect circle, you're insane. Like, and he would always say, like, mine are pretty close, right? Yeah, I can imagine massive whiteboard, perfect circle. Yeah, it's actually quite a small distance, so I'm kind of cheating with a mouse. Hey there, Nico. Thank you so much for the raid. Appreciate it, sir. Welcome, welcome. How you guys doing? Yeah, same or genius. What's the difference? Exactly. How does stream go? How does stream go? We are drawing circles, and we're ray tracing a BVH, so we can have a nice little debug view. Just finishing this boy up now. But yeah, how did the stream go? Madness fixed. Oh, that bug you wanted to fix for last week you showed me, wasn't it? Workaround IBM XIC icing when compiling. Oh, this is a different bug. Wait, is this Beehive still? No, it's different. GCLI. What is the IBM XL? Oh, it's a compiler. Proprietary optimizing compilers for IBM environments. Power and Z architectures. Like a Power PC or something? You have the most. This is my GC. Okay. Nice. Yeah, Power PC, fair play. Yeah, you have the most. Like. Yeah, I don't know anyone running a Power PC machine, Nico. You're definitely the biggest hipster I know. Wait a minute, Linux? Linux? Pretty dumb. Has it got a lot of bugs? Somewhat portable and secure CLA utility interacting with various Git. Oh, fair play. Nice. Oh, good old Storman. Don't worry, we got one for that. Yeah. Tasty. Give me that GNU. Isn't the Xbox Power PC or something? Yeah, Xbox was Power PC. No, PS3 was is it the cell architecture? Is that what it was called? Yeah, cell. Is that right? Maybe it's kind of power. Yeah, but it had like these SPUs and stuff, which I'd never programmed. So yeah, kind of interesting, I guess. You know. Yeah, it did say Power PC on it, but yeah, it seems like a different. Yeah, I didn't realize that though. That's news to me. That's news to me. So we've got to figure out if we hit a leaf node. So we hit a leaf node if this. Now I want to not make. I want to make sure my PC doesn't melt down. So I think I want to say if b dot children and this. We're just going to say, hey, is finish equal, is running equal false, right? So, oh, and then we need to say, so I was thinking that, you know, we have the left and right child next to each other in memory. And if that was a good idea or not. It probably is a good idea. We need to check the left and right node. You know what, should we just leave it only traversing down the left? And just see if that's a good idea. So you say something like BVH, because it's like a binary tree, right? Do that anyway. Bit fluffy on me, I know, right? It's the way he takes his sock off, and like someone asks him a question, and then he's just like nodding his head, looking, and then he'll like, you know, recline back, you know, put his leg up on his other leg, and take his sock off and put it on the desk, and then just start going ham into his foot with like one hand. Like, what are you doing? Like he's asking, some guy's asking about like licenses and stuff or whatever it is, and it's like got some serious question, and he's just going into his feet. Like, what are you doing, man? Like, this is the person who is leading, you know. But the thing is, me and Stallman have things in common, right? We've both written a C compiler of some kind, so yes, that might be my ultimate destination. We don't know, but okay. Until then. Um. All right, so I think we should test this boy out. Let's do max iterations. Should we? Max it. Let's do 10. But you know what? Let's not, because we'll probably go out of bounds anyway if it was a real bugger. Right, advance. Jobs are good. And right, let's just double check everything. We'll probably only go down the left for now, but that's fine. We can sort it out. So get the coordinate. We're dispatching over the whole screen. If we go outside the screen, return. Set up the camera stuff. It's all kind of hard coded. So we've got array per pixel, right? We've got a stack of BVH. We kind of stop when we get to the bottom, which means we don't actually traverse back up yet. That's fine. We keep running until that goes false. Set these guys up. Closest hit is positive. Right, we don't actually render out a pixel yet. We'll do that. So we get the BVH node with the BVH index, calculate the min-max, set up, work out Tmin and Tmax with this sort of bounding box collision. Wait, where's that is hit thing? We need to go back and get that. So if this thing is a hit, we do all this stuff. And then if our child node, yeah, right. Okay, so we just need to say if closest hit. So I think we can do a bit of a fancy blend. We can just basically invert the pixels. Because we can read from the output buffer. But we just gotta, it's in BGRA or whatever, so we've got to undo the BGRA. But it should be fine. Wait. No, we just invert it. We just ignore the alpha. So, yeah, so we need to load from a texture. We need to get ourselves the U32. Let's call it P for pixel. Incredible name, I know. So we need to unpack the pixel, and we just need to invert the colors. Does one take good enough in? No, technically you need to turn it from sRGB into linear and then do the inversion, because you get more, you get more like yeah, you get more data. Wait, what is it? In sRGB space, you sort of miss out the first part of, there's a good way to explain it. There is a good way to explain it, I just can't figure it out right now. But essentially, in sRGB space, there's less, like you basically skip over the first part of 0. So in sRGB to linear space, here you go. So sRGB looks like this. It kind of looks smooth. It looks linear, right? But that's sRGB space. This is linear space, where you get the black just goes off really quickly, whereas in sRGB the black stays on for a bit. And the reason why is because when like as soon as you start giving something light, it's automatically going to be bright, and there's not really a lot of gray, right? And so the reason why I use sRGB is because it packs down into a U32 better. Like when you've got 255, 255, or 256 possible values for red, green, and blue, you don't want to have the first sort of, the first 0 and 1 basically telling you really bright already, isn't it? Right? So that's the reason why I use, so 0, 1, step in 0, 1, 2, 3, integers. It's a little bit more smoother on the brightness. So because of this, if we have a value that's like here and then you invert it, it's not going to appear smooth, right? So I need to convert back to sRGB. flip that, and then convert it back into this space. Because if you used to have something here, convert into sRGB, sorry, into linear, it goes all the way down there. And then whereas if I had something like all the way up, all the way up, well, that was a really good way to explain it. So if there's one probably about here, it will go all the way down there to into linear. Whereas if I had something all the way up here and then flip it, it will probably end up literally just a little bit to the left. So it's like an exponential difference. I think that's the way to explain it. So yeah, that's the reason why we need to convert from sRGB to linear. Do the flip. Color dot x or RGB equal negate f32 times 3 color dot RGB, and then linear to sRGB. Flip the coordinate earlier, and then write the bugger back out. Jobs are good. Right. So let's try this thing out. Hopefully it works. You know what's funny about the XLC bug? I can't even report to IBM because I don't have a service contract with them. Well, I guess that's how they keep their business going. So there's no open source compilers for PowerPC now? Or do people like to compile on PowerPC with that compiler, so you have to kind of do it? Right, I need a float value for that, so there you go. What's this thing doing? Oh, T-min element. Oh, fair play. Because why not? Yeah. So why not, man? Rightio. BVH. Nearly there. Whereas that converter and float to a Boolean. Oh, no, wrong one. Closest. See, we haven't really... Oh, I wanted to do a color, but now I've just inverted it. Why did I do that? Why did I do that? Yeah, I should have just picked a color. Yeah, let's do that instead. So where's that HS... Wait, sorry, hue, saturation value. Right. Let's instead just pick a color. So we're going to random color based on the level. So we do a different hue. So the hue is going to be BV. We're just multiplying it by some big prime. Closest. Level. Ta-da. Should be called closest hit level. Something like that ought to be good enough. So CC will just get packed. We need to do the BRGB flip. Well, technically we don't, because we don't really have a specific color. Yeah. Cool. I claim portable tool on my GitLab, and I mean it. Definitely. It even runs on Linux. Right. So, we just had to launch the shader. So let's go into here. We're going to say BVH BVH viewer. I'm just going to set all of the properties up. So BVH buffer ID, BVHs. Don't know what else I had in there. Just BVHs. Bunch of BVH. All the BVH. So we're just going to go ahead and launch that boy. Across the whole display. And jobs are goodin'. I don't know, call it BC. Whoopsie. BC for bundle constants, my friend. Quickly just correct this. Right. Okay. See how this goes. Who has faith in me? Got 1 minute. Will it crash my GPU? Yes. No. Let's go. Pull. Always, mate. Nah. Yeah, new shader. Will it crash? This just about what BC meant. Nice. Yeah, it's just more of a portable name for push constants. It ran on Sparks. Yeah, that's the other esoteric thing I saw you have. Insane. And Solaris. Because why not? Wait, how did Striker get banned? Did he get banned on Twitch? And why did he get banned? Right, and the minute is up. Oh no. Last time around it, people believed. Oh, it's Dennis's Spark Station. The Wizard of Bits. He accidentally leaked his phone number, someone claimed. Someone called him on stream. Right. So he docks one of his viewers. Okay. Yeah, so I guess it's like, I can't ask you guys certain questions to sort of figure out who you guys are, basically. I see. I guess, yeah, you can't, a little bit silly. Yeah, it doesn't really count saying whose number. Yeah, that's true. Yes, I'm British. Yes. Right. 3, 2, 1, does it crash GPU? If it does, I'll be back. Right, let's go. Okay. So clearly we're drawing pixels on the screen. We're definitely not detecting the edge, are we? And the reason is because I did the check the wrong way around. This one. Is that right? We're in local space, right? Oh, we didn't absolute it. Whoopsie. So on the absolute, ABS. See, you wouldn't believe in me. Hey, I'm Get Payne, how you doing? Yeah, he did say it was Bob. Exactly. That's true. Didn't go ask is Bob's number. It's really silly. And also, did someone report it? Like, because surely Twitch didn't catch up on that. And I guess the person who he put the number up, I guess they reported him and said doxing, and Twitch just sort of were like, oh yeah. So, half dims in local space rate. Absolute of front. Okay, let's rework this one out. Hmm. Yeah, the person who did it was probably super happy that he got banned, right? Probably is a lot of fun for them. Is less than or is greater than? Why did I just say? I just said if it's non-zero. It was greater than T-min. Right. I was expecting that to disappear then. Um. Seems legit. Right. We haven't done any, you know, camera position in this, but it doesn't really matter because we don't move our camera yet. We've got to sort that stuff out at some point. But anywho, so you work out your team in, team max. It all seems pretty legit. Then you work out your. Oh, I said ray origin. What a scrub. Ray direction. Technically, it should be adding ray origin as well. So add ray origin. And since I'm sorting that out there, technically. No, it's fine. That's fine. All right, let's give that a go. Right. Changes. Clear changes. Ray origin plus multiply this by that. Um, subtract the center position of the bound, the BVH. Right, that definitely seems better. Ray direction times that, yep. So, hmm. Right, should we invert these and just see if that's wrong? I doubt though. Right, okay. So, I'm trying to think if there's a way where we can sort of see something but not everything. Wait a minute. So you're doing half dimensions, take away that. The absolute of that. Yeah, so technically you should get like a positive number. Um, yeah, that's definitely right. That's definitely right. Hmm. So we could debug this by computing a normal and just displaying that color and just basically seeing the walls. But the problem is I've got too many. I've got an outer one. I've got, you know. So why don't we just debug by saying let's only do it if we hit a certain one, and BVH index equal to, right? Right. Perfect. So we're getting one of the BVHs here now. This is the 2. This should be covering these 2 here, but we should only be seeing a border. So it is a hit. Let's just say it is a hit if it's equal to right, so that's not displaying the whole box, is it? Or not? That should be displaying the whole box. Because we're saying... Right, so something else is clearly wrong before... So we're saying box 2, which is this one. So we're saying it's got 0... 0 along the way. Right. So the y-axis clearly just has 10, isn't it? There's our problem. But I don't know how much of a problem it really is. Like we could have some more issues as well. Like because it was covering the whole screen for some reason. But yeah, so half dimensions. Well, it should be 1. So it should be 5. Because half radius. 5. 5. 5. 10. 10. That's it, right? Good, good, good. Okay. Take for a spin. There we go. A box. So the box doesn't look good. It looks like it's not doing it enough, right? So these are half dimensions. So you got a radius of 10. The sphere is 20. Right, so yeah, we're definitely wrong. So we should double all of these. So it should be 20, 10, 20. So all of them have basically got that. And then after that, we just need to simply complete the rest of the code, there we go. So there's a box surrounding the whole set of spheres. Now we simply just need to enable this code here, which should hopefully just show the border at pixel size. No. Yeah, that's right. That's it. Yeah, so it's just grouping the spheres. Yeah. So we're showing the second level. There's actually one more level as well, which groups two spheres. So that one groups the two boxes, which group the two spheres each. So this is still being like, I'm covering the whole. Did it compile? Compiled. Yeah, we've got the notification now, but it doesn't compile. So why is that? So we translate it into world space, right? So there's your hit position in world space, multiply, scale this to t-min, right? That's your front pixel. We could just do this one at a time, right? We could just check it front only. Let's do the greater than thing, see if that's changed. Right, then it doesn't render. Okay. Have I got to absolute this? I'm trying not to think right now, but we'll think in a sec if we get it wrong. Right. Okay. So no, of course we won't have to absolute that. Makes pixel size at that depth. Sure. Yeah. So right, so in local space, yeah, so it's the world position. Take away this world position. These seem pretty legit to me. So the minimum element out of, so we're subtracting the absolute of the local space from the half dimensions. So obviously if this is 500, we subtract like 100. Like we're 400 away from the edge, right? So as long as we're less than that, then we'll obviously be a pixel away from the edge. But we're clearly seeing the whole box still. Oh, it's front and back. No, is it front and back? No. The edge. No. Well, you're getting the minimum element. That's fine, yeah. The minimum between all of those. From the edge. Oh. It's always... If you should arrange this box, you hit, T-min always hits the edge. So you need to ignore the face with the normal. Right? So you need to get them... So depending on what edge we're actually on, we need to ignore that. So you need to get your dominant, your max edge, or your max dimension, and then ignore that one. Is that right? Yeah, so you need the middle, basically. You need the middle of all of those. You don't need the closest. But then you've yeah, you need the middle. So I guess to calculate that, it will be something like let's just make a function for it because I can't bother to make local variables. So in the middle, mid element. So you've got your vector. You just do a if v dot x less than v dot y. So you're returning y here. Oh, screw it. So this one you return y, the other one you return z. So else that means y is less than, so you're testing against y, then you're returning, then wait a minute, should you be testing against y here? Y is in the middle, if not z, then x be in the middle, if not z. Cool. So now we've got mid element, right? Instead, so it's mid element. That's what we want as the middle one. Cool, nearly there. So we got the border. It's a nice pixel, kind of, nearly, sometimes 2 pixels. But we're still drawing the front and back all the time. Why, oh why must that happen? So you always draw the front and back, but not the sides. Why? Could it be my mid thing? So let's just check it again. If y is less, sorry, x is less than y, then if y is less than z, then it's definitely y is in the middle. That means if not y is, z is greater than y, and then it's that. If no z is, but we don't know if it's in the middle or not, right? That's why, because on the z-axis it's buggered. Yeah, I did that test. Yeah. So x is less than z. So you don't know if y is in the middle then, right? Hmm. Yeah, so if x is less than z, you don't know which one is in the middle still. Yeah, that's right, isn't it? Yeah, so if v dot y is less than z, no, it's the same sort of problem, isn't it? Yeah, let's just do it the easy way. I can't be bothered. Yeah, because you can tell what is the min, but you can't tell what is the the middle. I think without 3 checks. Um, so if x is else um x is less than z else something like that, I think. So you've got to do the same thing. That'll be x and x, that'll be y, that'll be y. I think that's right. So I should get you the middle. Probably done better, but done. Magic. So there's our bounding box. It's still not, it's not perfect like a pixel. It's a rough pixel. That's all we need to know. Be good enough. So now we just let it do the rest. So bear in mind we've only done the left hand side. So we've still got to make this code repeat. So we're going to remove the explicit check for 1 box and we'll let it do 2 boxes. Woohoo! Right, so it's not doing the screen box for some reason. Is that too big? I wonder why it's not doing the screen box. So it draws these 2 boxes. So I was hoping for it to do a nice color. Oh, stack ID. Right, let's increment this. There we go. So we've got some good colors now. So we've seen 2 boxes. We should test these out. And BVH index equal 4. So that should be the one. Yeah, that one's way too big. So this is 4 here. 10. Yeah, these sizes wrong. Alright, let's give that a go. Oh no. So the X is right, but the other 2 are just wrong. So X is 10. Yes, this is why a computer would just be much better at making a BVH than me. There we go. So there's one, we'll do the other one. So it's only doing the left hand side for now. When we remove this. But I don't know why it's not drawing the topmost. There you go. So there's a left hand side one, which is this guy. So we might make them a little bit bigger so we can see the difference. I'm not sure though. Then we've got the right hand side which doesn't have one yet. So we could make them a little bit bigger. So let's increase. We'll make this one shrink to 9. This one also needs to grow probably by a pixel on every dimension. And that way, it won't be so tight and snug. It was 2 pixels. Or 2 units, whatever they are. There you go, now it won't be so snug. Right, so we've got the left-hand side only, and the root one's not drawing for some reason. Let me see why that one is. So it's probably because it wraps too much. Oh no, 0, 0. Yeah, the Z coordinate's wrong. The Z coordinate needs to be 105. Close. Should be wrapping these guys though. One oh. There's 105 because it's 100 and 110. Yeah, it seems to be a little bit bigger, I think, on the Z. Nope. So it's dead in the middle of the screen, right? The furthest left is well, it's negative 80 plus the half dimensions. Right, that's where it's going wrong. So it's 90. Right, and then 50. Yeah, 50 plus the half is 60. I think that's right. Gotcha. It's all in. Perfect. So I guess we should also read the depth buffer as well. Which we don't have a depth buffer, but we should make one for the scene. So we can depth test and not draw this. Right? Because that would be... Well, maybe you want it, right? Maybe you don't want it. Maybe you do. Yeah, maybe you should have an option. So this would then mean... So we're just missing now the right-hand side. So this is right-hand side. And so these are all left-hand side nodes, right? The root node, left, this one, and left. So you need to draw the right-hand side nodes of all the layers. So how are we going to do that in the shader? So we have in our BVH, we always have, so it's a tree which always has 2 children, right? So we basically just link to the first child, and then we just have its sibling next to it in memory. So we literally just have to repeat this code again. So we just need to know if we are a hit. Basically, given a BVH and probably some other stuff, it's pretty annoying. We could also just copy paste it. So we can share ray direction, we just need to recompute. So I guess we just do this And all the stuff we can share, we can just, in the higher scope, we just copy paste this. And, because it saves passing in parameters and so on, like function prototypes and that, right? It's just annoying. And then we just say, okay, well, BVH equal BVH index plus 1, and we go again. We could have done a for loop. And that would probably save... No, it wouldn't save on anything. Okay. So now we just got to do the traversal. So this will do the left and right of the root node, but it won't do the ones... But it will never take the right one if there is a hit. Okay. So what we need to do... So we've got this sort of BVH stack. So you need to keep track of the... I'm not sure if you want to do the 2 hit checks there and then. It might be worth doing it at the same time. Not sure, to be honest. Yeah, so if we run this code now, just have a look. It should have added a new... Double check that's fine. Yes. Oh, shoot. Damn it. Right, what GP crash? Ah, crap. Right, I'll restart the stream. BRB.